All right, so if we want to find this transformation form here, what do we need to do? Because I can't, if I wanted to graph this, I couldn't right now. How could we do that? What do we need to do with it? Well, in our transformation form, think about it like this. We usually have our a over x minus h plus k, meaning I don't have any x's up here. There's no x's in the numerator. So I need to make it so I don't have any x's up here, which means we need to actually do this division. So we're going to divide so that we can try and get this into our transformation form. So we're going to take our x minus 3 and divide it by the x minus 4. So to do that, we want to know how x times what will give us x, which is 1. So we're going to take the 1 times this whole piece and put it underneath. So we're going to wind up with our x minus 4 that we need to subtract from the line above. X minus x gives us 0 x's, which is what we want to happen. That first term should always cancel out. And then we have our negative 3 minus negative 4. So minus 3 minus 4. That would be if it was negative 3 minus 4. So watch out for that double negative. Correct. The double negative becomes a plus, right? So negative 3 plus 4. It's going to give us a positive 1. So watch out for those double negatives. They can be killer. In order for me to write this in transformation form, for my brain, I have to write it in what I call mixed number form, where we have the number on top with our fraction that has my remainder over what we divided by. My brain will not let me switch it without doing that step first. But that lets me get it into my transformation form of our y equals, our fraction goes first, the 1 over x minus 4. And then we have our positive 1 on the end. So in order to take something that is in what we call quotient form into our transformation form, we have to divide it. Where are we going to have asymptotes on this one? What is our h? Super close. I was going to say, it's going to be a positive 4, because think about our pattern being x minus h. This has x minus. So it's going to be exactly what that number is, so it's going to be 4. Our h is 4, which means which asymptote is going to be at 4? The vertical or the horizontal? The vertical. Our x equals 4 is our vertical asymptote. The v kind of fits inside the x. Is kind of the easiest way to remember that. Our horizontal asymptote is going to be where? Y equals 1. Our k is 1 over here. Our a is also 1, but we weren't asked necessarily about that. Okay? Questions on that one? I just wanted to kind of refresh on how we switch from quotient form back to transformation form, because we have one last piece we need to add in on our graphs. Because on Friday we talked about what to do when we had the cross-yowty bits, but we didn't actually get to graphing them. So today we're going to graph the stuff that has those cross-yowty bits, our discontinuities, the holes, the place where it looks like somebody came up and went and stabbed my graph. So today is our very last day of graphing. I know we are so sad. We weep. Our very last day of graphing. but that's okay. We are going to be on page 19 in the notes packet. Oh, snap. What? Yeah. Okay. So we're going to look at page 19, and we're going to try and graph this thing. I've got our transformation form kind of up there on the side so we can see it. But what we're going to do is we are going to try and figure out what the heck is going on here. So take a look at this one. Correct. Oh, that's lost. That's okay. I was like, how did this happen? It's in the middle. Okay. That's the investor doing all the chaos that the company should be on that one. She didn't hurt us, but not usually like that. All right. So looking at this, I know I can't go straight into graphing because we have an x squared in it. And we know our transformation form, we have x minus h in our denominator. So I need this thing to not be squared, for sure. So let's see what we can do to try and make this thing not squared. So what we're going to need to do is we're actually going to need to do some factoring here. That is not the stylus I use on the iPad. There we go. So what we're going to do is we're going to come through and try and simplify pieces here. So we want to see if we can factor things. So we're going to look at both our numerator and our denominator here. So looking at the numerator here, is there anything we can factor on this piece? Anything we can move around or change? Or is there anything they have in common on this minus 4x and 8? Super close. Let's say pulling out a 1 isn't going to change anything. If I take out 8, that will leave me with a fraction here, and I'd really rather not. A 4. They both have 4's in common. 4 and 8 are both divisible by 4. So I could pull out a greatest common factor of 4. I'm actually going to pull out a negative 4. I'm going to show you why here in just a second. So I'm going to show you what happens if we do this as a 4. So if I take 4 out, we're left with minus x plus 2, right? When we factor, do we ever get minuses here? We don't do that. So we don't want to wind up with a minus here either, because then we know for sure nothing's going to cancel out. And we'd really like something to cancel out because squares are gross. So it was left in here. So if we only take out a positive 4, the minus sign gets left in here. So I really don't want to do that. So what I actually want to take out is that minus 4. If we take out a minus 4, that's going to leave us with just an x here, which is so much more comfortable. We're going to get factors that have x's in the front. But then we have a positive 8 that we've removed negative 4 from, so it leaves us with a negative 2. So if we have a minus in front of our x piece here, be super duper careful with this. If I was to redistribute this out and multiply it back out, we'd get exactly what we have up here. But since we don't ever wind up with minus signs right here inside our factors, I highly recommend anything negative, we're taking that sucker out. We do not want a negative in front of our factor here. So then let's look at our denominator here. This is a squared thing, so this is a factoring. We're going to need our x frame. Our a is 1, so we don't need to use the box. Can if you want to, but we don't have to. So we need a pair of numbers that multiplies to make our a times c, 1 times 8, which is 8, and adds to be negative 6. Do we know a pair of numbers that multiplies to make 8 and adds to make negative 6? Two and 4 multiply to make 8 and add to make 6. How can I make it add to be a negative 6? I was going to say, they both need to be negative, right?
Wait, the negative, they both have
If the top number is positive, they're going to have to match. So they're either both positive or they're both negative. So if the top number is positive and the bottom number is negative, they're both negative. If the top number is positive and the bottom number is positive, they're both positive. If the top number is negative, we've got one of each. One positive, one negative. So just be really careful with that. That's one of those places that's really easy to mess up. And those signs do make a difference because even using our shortcut where we take our x with our -4 and our x with our -2, the signs are really important. What do we notice now that we have this in factored form? We've got a same factor in the top and the bottom. I can cancel out. Whoa, that is way too chunky. Holy cow. I can cancel out this x minus 2 piece. I have the same piece in the numerator and the denominator. So that leaves me with my y equals -4 over x minus 4. That's what we have left over. Is this in transformation form, or do I need to divide this like we did in the bell work to get it to transformation form? It's in transformation form because we don't have an x up here. If there's an x up here, that's when we divide. Since this is just a number, that's all right. We're good to go. So this is my transformation form. I don't have to do anything else to it. So we could from there start working on graphing. I'm going to go and catch my discontinuity first before we lose track of it. Because we need to pay attention to the fact that we crossed this piece out. That means this guy causes us problems, but only when it makes my denominator 0. So our x minus 2 equals 0 is the first piece of our discontinuity. So what x value is that that's going to give us a problem? If x minus 2 equals 0, what is x going to be? Positive 2. So my discontinuity is going to happen at the point when x is 2. To find our y, we take our x and we plug it in over here. So we're going to have our y that we get from our -4 over 2 minus 2. Nope, -4, excuse me. Helps if I write the right equation. There we go. I was going to be like, that's not working. When we simplify that, we get our -4 over 2 minus 4 is -2. -4 divided by -2 is a positive 2. So our discontinuity is going to happen at the point 2, 2. What that tells me is even knowing nothing else, someone is going to come up to my line, whatever it is, and they're going to stab it right there. There is going to be a hole. Someone will come and poke a hole with a hole puncher right there. So, even knowing nothing else, before I have any asymptotes, before anything else, I can plot that. It's not going to be a regular point. That means I have a value there. This is saying somebody stabbed it there. So I'm going to circle it. It's an open circle. That means there's a hole there. It is saying on the map, there is a lava pit right here. You best jump over it. So I have circled the lava pit on my map. Do not step on it. Don't draw your line on it, but we will go around. So the line will approach this, whether my graph goes like this and jumps over it, or if it goes like this, maybe my graph is way over here, but it's going to go through this point, whatever happens. So now we have our transformation form. We can get some asymptotes and we can get the rest of this graph because just that one discontinuity is not enough. So let's think through what our asymptotes are. Look at this guy here. Think about our A, H, and K. What is our A value? -4. What is our H? H is 4. And what is our K? Careful, careful. 0. There's nothing added on the end. So from that information, we've got our asymptotes. Our x equals h is going to be one of our asymptotes every single time. X equals h is our vertical asymptote. Again, the easy way to remember that is the v kind of fits inside the x. So our x equals 4 is our vertical asymptote. I can plot that up while we're here. We know there's an asymptote right there. And our horizontal asymptote, that's going to be our y equals k. So y equals 0. That means it's right on our x-axis. That's okay. I'm still going to put it there. Then to get any more points that we need, we make our own transformation table. So that's when we're going to take our parent function and do our transformations where we have our x plus h and our ya plus k. Well, we know our h, our a, and our k. So we're going to take our x values and add h. So we're going to add 4. Our y values times a. So we're going to go times negative 4 plus k, which is 0, plus 0. So we need to do this with our parent table, which we need that up here too. So I'm going to put my parent table down here, mostly because I'm running out of space. So this is our parent. The parent function is always what we have when a is 1, h is 0, k is 0. No transformations have happened. So that's our 1 over x. So if we don't remember it off the top of our heads, that's totally fine. Remember, it's always, no matter what function it is, it's going to be when a is 1, h is 0, k is 0. No transformations. Our good view of the middle, we have our negative 2, our negative 1, 0, 1, and 2, giving us y values of negative 1/2, negative 1. It's undefined. We have 1 and we have 1/2. So now we have what we need to do our transformation so we can get this thing finished up. Woohoo! So we're going to take our x's and we need to add 4. So negative 2 plus 4 gives us a positive 2. Negative 1 plus 4 gives us a positive 3. 0 plus 4 is 4. 1 plus 4 is 5. And 2 plus 4 is 6. Then taking our y values times negative 4 and then plus 0. So we have our negative 1/2 times negative 4 gives us a positive 2. Our negative 1 times negative 4 gives us a positive 4. The word undefined, I cannot multiply, so it remains the word undefined. Our positive 1 times negative 4 gives us a negative 4. And our positive 1/2 times negative 4 gives us a negative 2. So we have our points that we can plot up. We already have our discontinuity plotted, so we just need to be careful. We're not going to plot this point inside of it. We already have it there. It's our discontinuity. It doesn't really matter that it's in the table. It might be in the table. It might not be in the table. It's just giving us the information we need. So we know that there would be a point here, but it's where we have our discontinuity. And then at 3, 4, we have our next point. So that's this guy here. We have 4 as our asymptote. I want that to be erased up there, which is exactly what we see here. Then we have 5, negative 4, which gives us a point down here. And 6, negative 2, which gives us a point here. When we connect these up, we get a shape that looks like this. It still goes through that point where we have our discontinuity. It's just kind of like a lava pit. You got to jump over it. Or quicksand. Or whatever vague trap works in your way. So for the most part, it's the same as what we were doing last week. The only piece that's different here is when we have these crossy outy bits, we stab a hole in the line. And your discontinuity should always wind up on your line. So if you find your discontinuity and it winds up like way over here, double check, not just your discontinuity, but double check your line. Make sure we got what's going on, because your discontinuity will always be on one of your two curves. Questions on this one? Because we're going to do one more. We've got another one on this page. These are our last, this one's our last graph, our next one. Okay. So let's look at our next one here. Same kind of vibe. We're wanting to graph this. We want to get it in transformation form. We want to see what's happening here. So we've got this 2x plus 3 over 2x squared plus 13x plus 15. And we'd like to see if we can graph it, which means I see an x squared in my denominator, which means first things first, we need to see if we can factor this sucker. Because we know we cannot graph it if it's got an x squared in our denominator. So we need to look at our numerator up here and see if we can do anything to it. And we're going to look at our denominator down here and see if we can do anything to that. So looking at our numerator, this guy, 2x plus 3. Is there anything we can factor out of 2x plus 3? No. 2 and 3 only have a common factor of 1. That is the only piece they share. And factoring out a 1 doesn't really help us with much of anything. So our 2x plus 3 is just going to stay. I'm going to put it in parentheses to help us remember when we're trying to cancel stuff out, that we got to do it as a unit. Our denominator here, now we can do some stuff. Because I have a squared, means we need to try and factor this. I do also see that we have an a value. We have an a of 2, which means we're going to need our full kit. I'm going to need my x, and I'm going to need some other way of finishing out my factoring. I'm going to use the box. I don't care how you factor, just that you factor. Just show me what you're doing. So when we're filling in our x frame, that's when we're looking at our a times c at the top, 2 times 15, which gives me 30. That's our a times c. And our b goes on the bottom. That's going to be that 13. So we're looking for a pair of numbers that multiplies to make 30 and adds to make 13. 3 and 10. 3 and 10 will multiply to make 30 and add to make 13. But I can't just go straight into, x plus 3 and x plus 10. Because we have that a value, we've got to put it through the full box, because this tells me we've got a 3x and a 10x that are combining together after we've had our 2x squared and our 15 included. So it's uncombining our like terms here. What are we going to get as factors on the outside over here? What is shared between 2x squared and 3x? Top, just an x. How about our bottom row here with the 10x and the 15? A 5, good. How about our first column with our 2x squared and our 10x? Beautiful, love it. And our second column, 3x and 15. 3. So our factored form, we've got our 2x with a positive 3. Oh, snap what? And we have an x plus 5. What do we notice here? The 2x plus 3 cancels out. So we're left with our y equals 1 over x plus 5. Those are the only pieces left. Since there's not an x in the numerator, that is our transformation form. I don't have to do anything. If we were left with a factor on the top, that's when we would need to divide. But we don't have that, so this is my transformation form as it sits right there. I like to go back and catch that discontinuity before I continue with any other graphing, just so I don't forget. Our discontinuity is going to come from the fact that if our 2x plus 3 was equal to 0, my denominator would be 0. It would give me a problem there. So we need to figure out where that happens. So we need to solve this guy, and I'm just doing it kind of at the bottom under the graph because I'm running out of space. So how can I figure out what the x is going to be here? Subtract 3. So we get 2x equals minus 3. Divide by 2. So we're going to have our x equals, you can either say minus 3 halves, totally fine, negative 3 over 2, or as a decimal, because it's probably easier to deal with, minus 1.5. Like, that's what sometimes a little bit easier to deal with. So our discontinuity is going to happen when the x is negative 1.5. To find our y, we're going to substitute that into our leftovers. So the y we're going to get from taking our 1 over x minus, plus 5, but we're substituting in the negative 1.5 in place of the x. So we're plugging it into what we had left over. If we simplify that, we get 1 over negative 1.5 plus 5 is 3.5, which is fine-ish, but really unpleasant. If you divide 1 by 3.5 in the calculator, it is probably going to spit out for you 2/7, which is, again, usable, fine, not horrible, but graphing with decimals is usually easier. 2/7 is 2.8571428, blah, 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 blah. We're graphing, it's estimating. We can go with about 0.3. You could say 0.28. I'm going to go with a 0.3 situation here because it's easier to graph. And when we are plotting these up, we are getting it ish. We are not getting perfection. I am going to have visibly no way to tell whether you plotted 0.28 or 0.3. Our negative 1.5, 0.3 is going to be somewhere in this box. As long as the discontinuity is in this box, it doesn't really matter which part of the box it's in. It should be around here. I don't know why it had a curly Q in it. There we go. Should be about there. As long as you don't plot it like way up here, we should be fine. It should be in the box and not stressing about it. I tend to plot my discontinuity first and then go back and catch up on asymptotes and points. You can do it in whatever order works for you. It does not matter. Just know when we're graphing with the discontinuity, we need to jump over that hole. So just be careful. Our asymptotes are coming from our A, H, and K. So what is our A on this one? The negative 5 is something, but it's not the A. Yeah, the A is the one. Which one's going to be the negative 5? The H. Yep, you're right on it. I was like, I knew right where you were. You were just going for the first thing I was going to ask you about. But I like to throw things off and ask you different questions. So our negative 5. What's our K? 0. We don't have anything added on the end. So our K is actually 0. So that means our horizontal asymptote is actually happening at y equals 0 because it's always at y equals k. So our horizontal asymptote is right here, right on that axis, like that. That is really pale. I don't even know if that shows up there. I'm going to make those a little bit darker because, bless you, because those just were blending in. Is that better? Yeah, that's a little better. Okay, then our vertical asymptote happens at our x equals h. We saw that one too, our h being -5, so x equals -5 is going to be where we have our vertical asymptote. So that means our vertical asymptote is right here. Ooh, that is very aggressively bright. And then again, we need to make our own transformation table in order to be able to plot this up. I'm going to give myself a little barrier over here just because I have a lot of pieces and a lot of them are blue. So we're going to take our x plus h and our ya plus k. Our a is 1, which means y times 1 doesn't change. Our k is 0, so we're not adding anything. So our y's are actually going to be exactly the same as they are in our parent table. Our x's, we need to add our h, so we're going to add our -5, or we're going to minus 5. So our parent table you guys should have on the previous problem, but if not, totally fine. We can rewrite it down. Again, that's what happens when our a is 1, our h is 0, and our k is 0. It's the basicest of basic. There we go. With that good view of the middle for our pick of our x's, our -2, -1, 0, 1, and 2. Through our parent function, the most simplest, our 1 over x, we're going to have our -1/2, -1. It's undefined. That gives us our asymptote, 1 and 1/2. So that's our parent. We use that to make our transformations here. We are going to go times 1 plus 0, which does no change. So my y values are exactly the same. We're going to have our -1/2, our -1. It's undefined with our 1 and our 1/2. And that's going to go with our x's that we add our h to. So we're going to subtract 5 from our x's. So -2 minus 5 gives us -7. -1 minus 5 gives us -6. Then -5. Then -4. Then -3. That gives us our points we can plot up at -7, 1/2, or excuse me, -1/2, so down here, -6, -1. -5 is undefined. That's where we have our asymptote, so it gives us a little built-in double check on that. -4, +1. -3, 1/2. So when we plot this up, connecting up our dots, it should look like this. And on our right side, we just need to make sure. That was terrible. When we connect up our dots and approach our asymptotes, we're going to jump over our little lava pit here. And it should look kind of like that. So the only thing that's different on these ones with discontinuities is we have this little hole. It looks like somebody stabbed our graph. Okay? Questions on this one? Because that is actually our last graph in this section. Oh, snap. What? So you guys can now do everything on homework 4. So we just treat it exactly the same. We're simplifying, trying to find our discontinuities, and seeing what we can do. Okay, so you guys have about 5 minutes where you can work on 4, see what we can piece together, and go from there. So let me know if you guys have any questions. But that's what we're looking at.